Okay, welcome to part 3 of our discussion on LLMs. I'm once again joined by Sohrob Kazerounian, and we're today. So last time we tackled the topic of kind of what LLMs are and how we got to LLMs in the first place. Today we'll kind of concentrate on, in a generic sense, not just in a cybersecurity sense, how they operate and how you solve problems with them, and what problems they create as by virtue of how they've been constructed. So welcome back, Sohrob, and with that tee up, I'll let you kind of do a quick recap of what we talked about last time.
Yeah, so I think we sort of ended up, large language models, they sort of, at a certain scale and size, you get these interesting emergent properties and behaviors out of them. But at the end of the day, there's still sort of autocomplete machines, kind of on steroids, right? Like we really have to ground the way we think about large language models in the fact that, you know, based on some sequence of text that you've given it as input, it's effectively just trying to calculate basically what's the best, most probable output that follows from this, right? And so ultimately, at the end of the day, you know, the text prediction, when you think back to your, you know, cell phone 10 years ago, it's doing that, but at a much, much larger scale. Now, the gamble that was taken with large language models was that at a particular scale, these emergent properties will start to sort of appear. Yeah, it would seem magical, and you know, it was a certainly gamble. I don't think anyone could strongly say until the last 2 years or so that this was actually even feasible. But it's the capabilities these models have, you know, sort of are endowed with once you reach that scale is kind of remarkable. And so some of the things I think we'll go over today are, you know, what are the sorts of use cases, behaviors, how do they actually function, right? And so obviously, as a language model, you would think, you know, this is good at producing language, right? And it's certainly true. It can, you know, you look at the use cases, people have used it for write me song lyrics, or, you know, I have a friend, for example, whose favorite use case for ChatGPT is writing recommendation letters for other people. They're happy, he wastes no time or whatever, and he's blown away. He thinks this is unbelievable technology. And it's interesting because, you know, while it's incredibly good at dealing with natural language and text, there are so many other use cases and different domains you could be applying these large language models to that essentially it's a very limiting to think of it just as, you know, these one-off use cases, right?
Yeah, and recommendations are kind of like an interesting thing. It's like you're trying to get a certain sentiment across without it needing to be super accurate, you know, it just needs to basically, particularly if your friend, your buddy sees it, feel like, hey, you put effort into it and you said nice things about them. And if the person kind of reading the recommendation sees it, it's like, oh, this person seems to like this other person and seems to think that they do reasonable things. And it's like, it's not trying to convey very precise information, right?
And it's a good domain to be in because the squishiness of it means you can get away with a lot, right? You can be inaccurate, but as long as people are happy, then it doesn't really matter. And so the natural language cases, the sort of toy examples that people, you know, using it to write lyrics, all very nice. But then in these sort of more technical, more scientific, more mathematical, whatever you want to think of it, these other domains of application where it is actually, or even like, you know, natural language, but, you know, an exam of some sort. Those are cases where it's like, okay, this is really, you can do some wild stuff with this, right? So, you know, for example, one of my favorite early on sort of examples that went viral, I think, was asking ChatGPT to produce essentially a runtime analysis of bubble sort, but to do it in the voice of a 1940s gangster, right? And so, like, you know, the response ChatGPT gives is like, all right, pal, listen up, da da da, and the runtime complexity of the algorithm. And it's basically not only giving you a correct analysis of this, you know, algorithm, and it's giving you code examples and referring to it, but it's also doing it in this 1940s gangster voice that, you know, is just incredible capability that you wouldn't, again, it's not been trained to do these things. It's just a sort of ability that emerges from that scale.
you can see tinges of the actor strike and the writer strike, when they look at stuff like that, right? Because it's like, yeah, for that you would typically hire somebody and say, okay, write in the mode of, here's the storyline, but now write dialogue, based on this character having this particular life story and backstory.
Yeah.
That's kind of easy to pop into one of these systems and just have it do it for you, right?
100%. And I would say it's more than even just tinges. Those strikes are very much centering, the idea that you could replace actors, writers with these models one day, and oftentimes you'll have to sign away, if in perpetuity the studio can, use my data and train these models and reproduce what I would have said. So it's
So you've talked a little bit on autocomplete so far, right? So it's autocomplete, but as we one of the interesting problems that I think people tend to have trouble kind of wrapping their heads around is like, well, why does it give the different answer each time I ask it the same question? And is it because it's learning from everybody else's questions? Is it like what's causing that really? So talk a little about that and temperature, I guess.
Yeah, it's the temperature. It's an appropriate time to talk about. So these language models are forming a probability distribution over next tokens, next words, the sentence structure as a whole. And because, the example we've used a couple times in the last couple sessions is basically the cat in the, right? Surely the cat in the hat is the next most likely completion. That doesn't mean every single sentence that starts with the cat in the should be completed with hat, right? And so if you think about your neural network, essentially when you feed as input the cat in the next, the next token or next word or whatever should be a probability distribution over possible completions where maybe hat is the likeliest, but maybe it's, maybe the cat in the room, maybe the cat in the, forest, all of these other possible completions
have a non-zero likelihood, right? And so then the kind of interesting question becomes, so if you had, let's say, a weighted set of 100 potential outcomes where 50 of them were hat and 20 of them were something else, room, and 10 of them were something, I mean, is the system simply basically running a random number generator, picking a number between 1 and 100 and choosing hat if it's below 50 and choosing, basically room if it's between 50 and 70? I mean, is that roughly logically the way to kind of think of it?
Kind of, yeah, actually. So you could think of this temperature parameter in in a greedy setting, it would say, hey, let's not even run this random number generator and sample from this probability distribution. Let's just take the next most likely word every single time. And in the case of the cat in the, hat is the likeliest. In this case, you would say 50 out of 100 cases it showed up, so it's the highest probability. Let's just say hat. You could change the temperature to reflect actually 50% of the time hat should come up, 20% of the time room should come up, and so on and so on and so on. And now a perfect reflection of that distribution would say, let's make it resemble the actual distribution of observed data. On the other extreme, you could say, let's ignore that probability distribution altogether and just assign a uniform, sampling of
whether it's a fringe outcome or a very popular outcome, that the likelihood of them appearing is basically the same.
Yeah, or even a non-syntactically correct one, like the cat in the, exists.
Yeah, it's again, I think people tend to think of these systems being designed, and this is the wrong way to think about them. The systems are not designed to give you the truth. First of all, the problem with that anyway would be you'd have to actually adjudicate what the truth is. If you ask 10 people, 10 chefs, master chefs on how to cook risotto, it doesn't mean you get the same answer 10 times. It basically means that maybe 6 of them will use a pretty common technique. A couple of them will have some other thing, other way they do it, and they swear by it, right? And that doesn't make those things less true. And so the question is, do you want the variety of potential thoughts and outcomes and answers to be reflected in a system like this? Or do you want to prune out everything but the most common answer, which sounds great because it gives you consistency, but it then means that you lose all of the nuance across the world of, views that may ultimately be correct, but are currently somewhat more fringe? Do we really want to cut all the fringes out? And the answer is probably in a knowledge-based system, no, we don't want to do that. But then to expose ourselves to those fringes, it creates this degree of variability basically in the system.
Yeah, and that variability is annoying on the one sense as a developer if you're productionizing the idea that, like, it could give a different answer. On the flip side, as somebody who, let's say you cooked risotto, it's kind of nice to be able to see, oh, there's this recipe, but also this recipe, and exploring the space of possibility there is actually not just for in the squishy territory where truthiness doesn't matter, like risotto cooking, but even in the space of ideas where you can evaluate whether or not something actually is true. It is sometimes good to entertain possibly.
So much invention is taking this person's risotto recipe and then in this one critical step, adding this one technique that this other person told you about, right? And fitting it in. And that's where creativity comes from. And so if you basically cut all of that out, then you just have this kind of flat landscape where there's only one right answer to any one question, right? And yeah, that's not a fun world to live in, quite frankly.
Definitely not. And
now,
so
yeah, go ahead.
I was going to say there's this temperature issue, and it's slightly different, or it's there's a different thing on the hallucination side where when we ask it to answer a question, right? If I ask ChatGPT, like who's actually a nice example that came up from our own SR team, Dimitri searching for, what was the start date of the war between Russia and Ukraine? Well, OpenAI has a cutoff date after which they did not take any data, and that cutoff date was September 21, before the war in Russia started. Right. So in principle, if it says anything about when the war in Russia started, it's essentially making up an answer just to sort of, not. It's hard not to anthropomorphize here, but to please the person on the other end, right? If you ask it a question, it'll tell you an answer. It's essentially, a great bullshit artist. Right? Now here, interestingly, there's a situation that Dimitri found that actually when ChatGPT responded, it actually knew the date of the war between Russia and Ukraine. And the reason here is that basically OpenAI hasn't been totally transparent about what data they're using and how they're using that data to update their models, right? And so in this case, it's quite likely that through user feedback and sessions, some number of people were actually interacting with the models asking about Russia, and OpenAI will have curated some of that data to go in and fine-tune the model to improve its performance. And so you get leakage potentially of, you have this cutoff date, but other things might come in through downstream sort of nudging and RLHF and supervised fine-tuning and so on.
So you have leakage of future information kind of dribbling in, even as the base model was trained up on against a pretty stark point of demarcation. There are other ways, again, which are, as you and I have talked about it before, like when you think of reinforcement learning, it's not that is fully automated in the sense that if 5 people today have a conversation with ChatGPT and tell it something that 5 minutes later, when I ask it a question, that has leaked across. But the feedback that does come back in is utilized in let's say not as real-time a manner, in a way by OpenAI to kind of improve the model, and so it may leak in over the next week or over the next month or whatever their methodology is, right?
Yeah, exactly. And anytime you open up one of those feedback systems to the public, obviously you have to curate that data that you're getting back, because we've seen actually chatbots go off the rails because you let the public basically do what they want to the model, right, and train it how they want.
Yeah. Racist chatbots are certainly common, and certainly, well, just think of this in the human sense. Like, think of some even a crowdsourced thing like Wikipedia, right? If you just let humans with reckless abandon make changes, then everybody decides to create their version of the truth and to try and game the system in certain ways. So you have to have controls in place, and those controls are what puts some damper between that feedback and it becoming immediately active.
Yeah. So ultimately on the hallucination point, and I think maybe we'll come back to this in a future episode on sort of the ways to think about it, but if you were to be asked a question about what I think about something, you could probably simulate a good response of me answering that thing. but it doesn't mean that that's what I actually think about that question. It's just your best simulated version of it. Yeah,
it's a believable answer that Sohrob might have said, and it passes maybe initial muster, but it may, in fact, even on secondary thought, if you knew Sohrob and you knew his opinion about something, and you extrapolated from that to the likely answer to the question in hand, that you might even come to the conclusion that that's likely wrong. But that takes a fair bit of connecting the dots to kind of come to that conclusion. On the first order, can I answer the question in a way that Sohrob, in the style of Sohrob? Yeah, that's that's a degree of mimicry almost, right?
Exactly. For sure.
Cool. So let's talk now about there are obviously different ways, and we've talked about this even internally. Like when we did our demo internally of some of the Vectra UI, there's this notion of, hey, can we come up with just a natural language to VQL translation, to vector query language translation? And that feels very different than the experiences that most people tend to have inside a chat window at ChatGPT. So describe to me like the various forms of kind of interaction with chatbots and LLMs and what the implications of those things tend to be.
Yes, there's a number of ways. You can structure the back and forth between a chatbot and a user. What OpenAI did really well with ChatGPT was actually the UI UX side of it was really, really elegant, right? And so when you use ChatGPT, it's very conversational. I can have these long sort of discussions, and the model can refer back to things in prior portions of the conversation. If for example, the model says something that I think is incorrect, I can ask it to go back, correct itself, and so on. And the way it's doing that, when I interact with one of these language models, I'll give it an input, it spits out an output. That's your one-off interaction. Now, to make it feel conversational, the way you do that is essentially you take my input, take its output, and then if I ask some new input, I'll take both the input and output from the previous interaction, and I'll prepend my new input or question or ask of the model. I'll prepend it with that data. So as part of the input now, you have this conversation history.
So you're just running conversation and you keep feeding back a longer version of the running conversation. Not terribly efficient, right? Because you would think from a statefulness, like when we think in computer science terms, it's like, well, you've already processed that. Is there some intermediate state you can capture? But it's also stateless. It means the system doesn't really need to have any fancy remembering of state and stuff like that. But then the conversation becomes longer and longer. And is there like a limit on how long that conversation can become, I guess?
Yeah, there is, and it's a painful one when you reach it, right? So you'll often refer to it as the context window, or essentially these are the bounds on how long your input can be and how long your output can be. And at the moment, you're talking roughly 2,000 to like 32,000 tokens. Now, the interesting thing is that the context windows are getting larger and larger and larger quite quickly. A number of research papers even coming out that say you can do millions of tokens. That's roughly a 3,000 page book, right? That can all be used to feed in a single pass, right? So you could imagine
a huge computational cost, though, you would think, right? I mean, because you'd have to basically reprocess all of these tokens and get yourself into the appropriate state to answer just that one extra question at the end.
Yeah, it's not cheap, and a lot of the effort is essentially finding these computationally efficient ways to make those windows longer. Now, the interesting thing is that it helps on the conversation side. If I have a long, you can imagine a lifelong AI bot that grows with you from childhood onward, right? Maybe that one you'll want some long context window or history or whatever.
Where death is when the window runs out.
Exactly.
Well, it's not really death, because at that point you could fix things by deleting parts of its memory banks, i.e. deleting part of the lifelong conversation you've had with it at the cost of it losing that information, right?
And actually that's currently what ChatGPT does. If you have a long enough conversation, the parts that trail out because they're now being pushed out of the sort of context window, it starts to you start to see drift, and it gets a little off the rails, right? Now, the interesting thing here is that this is how ChatGPT feels conversational, right? but there's also these context windows necessitate a different way. The context windows plus the cutoff dates kind of require you to have a different way to feed data into these models, right? So let's say, for example, all of our knowledge base articles, detection one pagers at Vectra, Confluence documents, and so on. If we wanted to use that as a sort of data store for ChatGPT or some other model like it to be able to answer questions, converse with you, and so on, you can't just feed that in as context in the input window because it's just not going to fit at the moment anyway, right? So there is another technique, retrieval augmented generation, which says, why don't we store the data that you care about in a now commonly used as a vector database, where we'll take the data you want, vectorize it, come up with this mathematical representation for it. And then if I have a question, for example, asking about, let's say, our external remote access detections, I'll take a vector representation of my question, search in that database for the closest articles that might be relevant and might be good to have as context. And then I'll feed all of that context in at the same time as my question and let the model answer it in that sort of,
So you're basically prepending, you're selecting kind of a cluster of documents using this kind of vectorizing process, but then letting ChatGPT and its kind of core based model operate on that as if that was all prepended to the question at hand.
Exactly.
And as long as you've done a reasonable enough job that you found the likely culprits, the likely documents in which the answer could be found, then it's like it all works fine, right?
Yeah.
And it's far more efficient than feeding the entirety of the knowledge base in.
Yeah.
Not to mention that it might not fit into the context window anyway, right?
Yeah, exactly. And it's
so
a
that's
difficult balancing act, right? Those context windows. Yeah.
Where you're taking kind of a hive of knowledge and trying to augment the system in a way that naturally fits kind of with the ChatGPT thing. But then there's the other thing. It's like, well, what if you want to expose it to a certain store of data? Like, here's an API that gets you answers to a bunch of questions, or here's an API that has certain kind of capabilities. What do you do with those kinds of things? Because those are not really, like when you think of Microsoft Security Copilot examples, right? It's like, oh, and then it reaches out to your Graph API and pulls this information. That's not a global corpus of data that you would want to train a model up with anyway. That's a contextually at this moment in time for this customer, here's their information. How does that plug in?
Yeah, so the model's spitting out text, right? So then how do you get text to do things downstream, right? And so a number of frameworks are being built up right now around language models that sort of abstract away a lot of the interaction pieces, but also allow you to develop plugins, to create agents that can essentially, you're giving the model the ability to pull levers, push buttons, do things in the real world, right? And one of those things, for example, is to be able to reach out to, let's say, another data store or data source and be able to interact with it via API or via whatever mechanism that you want to enable. And so essentially, there's now an ecosystem of plugins and connectors that are being built up for these kinds of things, right? So to an earlier point, GPT is basically just autocomplete. It's not the greatest. It's, if you ask a mathematical question, it's effectively just sort of what's in the text, what's an answer that looks like it would have fit in here.
But what's 72 times 17 is like 3,000?
Yeah. It'll give something that feels maybe roughly from some data store like it's a data set like it's a right answer, but not actually. So there's a plugin, for example, now for actually if it's a mathematically relevant question, or if you're asking it to solve something, reach out to Wolfram Alpha, write
the query, basically give it structure, basically teaching ChatGPT how to prompt engineer its way into Wolfram Alpha, where Wolfram Alpha has much stricter grammar potentially, right? And so all that ChatGPT needs to do is take your more amorphous question and express it in a way that honors the grammar that is expected. And so again, what ChatGPT is doing is translating from one dialect to another, which is kind of what it's good at, right?
Yeah, and there you let essentially Wolfram Alpha, or I think there's a number of Travelocity or whatever, these other plugins that exist, that you let those things do the thing that they're good at. Wolfram does very.
The example, I mean, the good example of this is like distances, travel distances, right? It's like, yes, would you really want to take the entirety of all the roadways on the planet and plug those into the model so that the system would have an innate knowledge as to how long it would take to get from Boston to Philadelphia? Probably not. Not to mention the fact that, oh, by the way, there's road construction right now and this bridge is out or something like that. So in lieu of that, when you want a precise answer that requires either computation or requires knowledge of a lot of background data in order to then compute something across it, can we give you can we give ChatGPT a means by which it can interact with a system that can give it those answers?
Yeah, and the plugin world, things like LangChain, these frameworks, those are sort of the primary mode of doing that at the moment. The newest one, Code Interpreter for ChatGPT, is basically you can ask ChatGPT to write Python code, but it may or may not have mistakes, right? So what they've done is given it a sandbox Python interpreter so it can run the code, analyze the results, iterate, and actually give you code now that not only is more likely to run and actually be the thing that you're asking for, but also you can now feed it a data set and ask it to generate plots, graphs, And so there's a lot of utility in connecting the model to the different sort of aspects of the world that it would want.
And then you get to Skynet, right? It's like, okay, we're going to connect it to all these things that can do things, and then now our imagination of how far that could go.
Yeah, luckily we won't go too deep on the end-to-end automation autonomous thing, but the real scary thing is that actually they make a lot of mistakes, and people are going to plug them into all the things anyway, right? So it's going to be a scary world, but in a different way than Skynet.
I guess what is the most likely scenario that unintentionally one of these LLMs will destroy the planet, or that it will become sentient and decide that the human race should be eradicated? What's the over under on those two scenarios, I guess?
Yeah, I think the likeliest scenario is just they're stupid and people are going to let them do the things anyway, right?
Yeah,
and that'll be the one.
Yeah, the unintentional side effects, I agree with you, are far more likely than sentience and deviousness in deciding how to solve for that. Cool. So the final piece then for today is just like, okay, so does ChatGPT end up replacing all kinds of knowledge workers? That tends to be kind of like the question. And I think from what we've said so far, the answer clearly would be no, unless you wanted to destroy the planet, because the answers won't be correct. They'll be in the style of, and they'll be sort of correct, and they'll sound sort of good. So how do you think of that?
Yeah, so I think ultimately, in some sort of, the irony here is that we thought AI is going to take over manual work and In some forms of cognitive labor, where there's less of a degree of like, this is correct, this is not correct, or there's a huge risk to being incorrect, it will automate away certain types of work. Copywriting, for example, I think, PowerPoint generation, whatever, stuff like that will, start to feel less and less like a viable career path. But the saying I think I like the most is that GPT is not going to replace coders. LLMs will not replace coders. Coders with LLMs or coders with ChatGPT or whatever, they're going to replace coders without LLMs or coders without ChatGPT. And so the sort of feedback loop and the efficiency gains and speed gains and ability to access a world of data, that increases your ability to do things.
But it becomes largely kind of like other technology curves that we've been on, right? It's like, if the technology in question that has been invented increases efficiency quite a bit, then there is really no option not to use it, because if you don't use it, you will not be competitive vis-a-vis people who do, or people, organizations, whoever, who do use something, right? And I think that's where we really find ourselves, is we have to get good at living alongside these things, rather than fearing that they will necessarily replace things that we will do. Because certainly in the cybersecurity realm, I can say the good guys and the bad guys will adopt this stuff, and it's an ever escalating thing, right? We're not solving a fixed problem. We're fighting, we're playing chess against other humans, and in as much as those humans augment, we will need to augment as an offset to that, quite frankly.
Yeah, totally.
So it'll be interesting. Cool.
Yeah.
So next time, just to plant the seed, we will begin to actually talk specifically about LLMs and their application to cybersecurity, both for the bad guys and then eventually for the good guys. So that'll be kind of, again, more focused away from the general applications of LLMs to something that is more near and dear to our hearts. So until next time, thanks a lot for watching this session.